Deep in the cosmic void, radio telescopes have discovered something that challenges everything we thought we knew about the structure of space itself. Imagine perfect circles of radio energy, each one spanning hundreds of thousands of light years across, appearing as ghostly rings that exist only in radio wavelengths, while remaining completely invisible to optical telescopes, infrared detectors, and X-ray observatories. These mysterious structures, dubbed odd radio circles or ORCs, have appeared in our surveys like cosmic crop circles, written across the fabric of the universe. And their discovery has left astronomers grappling with a profound question. What if these enigmatic formations represent something far more extraordinary than conventional astrophysics can explain? What if they are glimpses of higher dimensional physics leaking into our three-dimensional reality, potentially serving as gateways or windows into parallel universes that exist beyond the boundaries of our observable cosmos? Since their first detection just 6 years ago by Australia's ASKAP radio telescope, only a handful of these cosmic enigmas have been confirmed, yet each discovery has deepened the mystery surrounding their true nature. The most recent and most powerful ORC ever discovered, designated RADJ 131346, 9 plus 500,320, consists of two overlapping circles of radio emission that stretch across 300,000 light years each, surrounded by an even larger radio cloud extending nearly 3 million light years across space. Located at a staggering distance that places it nearly 7 billion light years away, this cosmic formation existed when the universe was only half its current age, suggesting that whatever creates these structures has been operating throughout cosmic history. What makes ORCs truly extraordinary is their complete invisibility across most of the electromagnetic spectrum. While they blaze brilliantly in radio wavelengths, they emit virtually no detectable light in optical, infrared, or X-ray frequencies, creating the unsettling impression of structures that exist partially outside our normal physical reality. This selective visibility raises profound questions about the nature of the matter and energy involved in their creation, as most known astronomical phenomena produce signatures across multiple wavelengths of light. The radio emissions themselves consist of relativistic, magnetized plasma moving at significant fractions of the speed of light. Yet the source of this plasma, and the mechanism that arranges it into such perfect circular geometries, remains completely unexplained by conventional astrophysics. Current scientific hypotheses for ORC formation include shock waves from merging supermassive black holes, galactic superwind outflows from massive star formation episodes, or blast waves from powerful extragalactic events. Yet none of these explanations adequately account for the observed properties of these cosmic rings. The perfectly circular symmetry, the enormous scale, and the selective radio emission suggests that whatever creates ORCs operates according to physical principles that we have not yet identified or fully understood. Detailed polarization studies of ORC J0356-4216 revealed magnetic field structures that align tangentially with the ring geometry, with fractional polarizations reaching 30% along the outer edges. This magnetic organization implies a coherent process operating over scales of hundreds of thousands of light years, far exceeding the typical scales of known astrophysical phenomena. The discovery of overlapping ORCs, where two separate rings intersect in space like a cosmic Venn diagram, provides tantalizing clues about their potential connection to higher dimensional physics. In theoretical frameworks derived from string theory and M-theory, our familiar three-dimensional space represents merely a slice of a much larger 11-dimensional reality, where additional spatial dimensions remain hidden from direct observation, but can influence physical processes in our observable universe. These extra dimensions, compactified into incredibly small scales according to current models, could theoretically manifest their presence through gravitational effects or exotic field configurations that create observable phenomena in our three-dimensional space. The concept of branes in M-theory offers a particularly intriguing framework for understanding how ORCs might represent dimensional interfaces. In these theoretical models, our entire universe could exist on a three-dimensional membrane floating in higher dimensional space, with other parallel universes existing on separate branes nearby. Interactions between these branes, or the passage of exotic objects through the higher dimensional bulk space, could create disturbances that manifest as circular patterns of energy emission in our observable reality. The perfect geometry of ORCs and their enormous scale might reflect the mathematical precision inherent in higher dimensional geometric structures projected onto our three-dimensional space. Recent advances in our understanding of exotic matter and negative energy densities provide another pathway for interpreting ORCs as potential dimensional gateways. In general relativity, the creation of traversable connections between distant regions of space or between different universes requires matter with extraordinary properties, including negative energy density and pressure that violates the weak energy condition. While such exotic matter has never been directly observed, quantum field theory predicts that certain configurations of quantum fields can produce localized regions of negative energy density, particularly in the vicinity of strong gravitational fields or in association with vacuum fluctuations near event horizons. The radio emissions detected from ORCs consist of synchrotron radiation from relativistic electrons spiraling in strong magnetic fields. But the ultimate energy source powering these particles remains mysterious. If ORCs represent interfaces between our universe and higher dimensional space, the observed radio emission could result from the interaction between ordinary matter and exotic field configurations that exist partially in dimensions beyond our direct perception. The process might resemble cosmic-scale versions of the Casimir effect, where quantum vacuum fluctuations create measurable forces between nearby surfaces, but operating across dimensional boundaries rather than simple spatial separations. The phenomenon of false vacuum decay, recently demonstrated in laboratory experiments with ultra-cold atomic gases, provides another theoretical framework for understanding how ORCs might represent dimensional transitions. In quantum field theory, false vacuum states can undergo sudden transitions to lower energy configurations through the nucleation of expanding bubbles that propagate at the speed of light. These bubble walls, where the field configuration rapidly changes from one vacuum state to another, could theoretically create observable electromagnetic signatures as they interact with matter and radiation in their path. If ORCs represent the aftermath or ongoing process of such vacuum transitions occurring in higher dimensional space, the circular geometry would naturally emerge from the spherical expansion of transition zones projected onto our three-dimensional reality. The discovery that some ORCs show evidence of expansion, with apparent velocities reaching significant fractions of the speed of light, supports scenarios involving dynamic processes rather than static structures. Analysis of ORC J0356-4216 revealed size differences between its northern and southern components that could indicate expansion at approximately 0.28 times the speed of light, though this interpretation remains tentative. Such rapid expansion rates would require enormous energy inputs and suggest processes operating under extreme physical conditions that challenge conventional astrophysical explanations. The selective visibility of ORCs in radio wavelengths might reflect fundamental properties of how higher dimensional physics manifests in our observable reality. Theoretical models of extra dimensions often predict that certain types of fields or particles can propagate through the additional spatial dimensions, while others remain confined to our three-dimensional brain. If ORCs result from higher dimensional phenomena, their radio-only visibility could indicate that the physical processes involved couple preferentially to electromagnetic fields at specific frequencies, creating a narrow observational window into otherwise hidden physics. Recent developments in ADS/CFT correspondence, which relates higher dimensional gravitational theories to lower dimensional field theories, suggest that phenomena occurring in higher dimensional space can have precise mathematical relationships to observable physics in lower dimensions. These holographic principles imply that complex, higher dimensional processes could manifest as relatively simple patterns in our three-dimensional space, potentially explaining the elegant circular geometry of ORCs as projections of more complex, higher dimensional structures. The magnetic field configurations observed in ORCs, with their remarkably ordered tangential alignment around the circular structures, bear striking resemblance to theoretical predictions for the electromagnetic signatures of exotic space-time geometries. Computer simulations of magnetized plasma in curved space-time, particularly around objects with unusual topological properties, often produce highly organized magnetic field patterns that could account for the observed polarization characteristics of ORCs. The extreme coherence of these magnetic structures over scales of hundreds of thousands of light years suggests organizing principles that operate beyond the reach of conventional astrophysical processes. The energy requirements for maintaining coherent structures on the scale of ORCs challenge our understanding of energy transport and dissipation in cosmic environments. Calculations based on synchrotron emission models indicate that ORCs contain cosmic ray electron populations with energies comparable to those found in the most powerful radio galaxies, yet without obvious central engines to power such massive particle acceleration. If these structures represent interfaces with higher dimensional space, the energy source could originate from regions beyond our observational reach, with only the electromagnetic byproducts visible in our three-dimensional reality. The recent discovery of ORCs with complex internal structures, including multiple rings and asymmetric features, suggests that the underlying phenomenon involves sophisticated physics beyond simple blast wave or shock front models. These morphological complexities could reflect the intersection patterns created when higher dimensional objects pass through or interact with our three-dimensional space, similar to how complex two-dimensional shadows can result from simple three-dimensional objects moving through a plane. Quantum entanglement experiments have demonstrated that particles can maintain instantaneous connections across arbitrary distances, leading some theoretical physicists to propose that entanglement itself might represent a form of connectivity through higher dimensional space. If ORCs represent macroscopic manifestations of similar higher dimensional connectivity, they could provide observational access to quantum mechanical principles operating on cosmic scales, potentially revealing new aspects of the relationship between quantum mechanics and general relativity. The distribution of ORCs in space shows no obvious correlation with known large-scale structures, like galaxy clusters or cosmic filaments, suggesting that whatever creates them operates independently of conventional gravitational clustering. This independence from normal matter distributions could indicate that ORCs result from processes occurring in the higher dimensional bulk space that surrounds our three-dimensional brain, with their positions in our observable universe determined by geometric relationships in dimensions we cannot directly perceive. As radio telescope technology continues to advance, astronomers expect to discover many more ORCs in upcoming surveys, potentially revealing whether these structures follow predictable patterns or represent truly random phenomena. The statistical properties of a larger ORC population could provide crucial tests of different theoretical models, distinguishing between conventional astrophysical explanations and more exotic scenarios involving higher dimensional physics or connections to parallel universes. The possibility that ORCs represent gateways to other dimensions remains highly speculative, Yet the mysterious properties of these cosmic structures continue to challenge our most fundamental assumptions about the nature of space and the limits of physical reality. Their perfect circular symmetry, enormous scale, selective electromagnetic visibility, and coherent magnetic field organization suggest the operation of physical principles that extend beyond our current theoretical framework. As we stand at the threshold of a new era in radio astronomy, with next-generation telescopes promising to reveal thousands of new cosmic phenomena, ORCs may represent our first glimpse of truly exotic physics operating on cosmic scales, potentially opening windows into the hidden dimensions that theoretical physics predicts, but observation has never before revealed. Whether they prove to be manifestations of unknown astrophysical processes or genuine signatures of higher dimensional reality, these enigmatic circular structures remind us that the universe contains mysteries that continue to transcend our deepest theoretical understanding, inviting us to expand our conception of what is possible in the vast cosmic arena that surrounds us.